In this video, I want to look at the graphs of quadratic functions. So this is generally considered one of the, if not the most difficult topic in National 5. It does cause a lot of confusion among students. There's a couple of things that you can try and keep in mind that does make it significantly easier. Let me just quickly demonstrate. So if you've got a quadratic graph, then that's going to be a parabola graph, like a U-shaped graph. So those graphs can be anywhere on the xy plane. You know, they could be up here, they could be down here, they could be upsides down, they can be anywhere, right? But a typical parabola graph might go something like this. And if it goes like this, then it's got a y-intercept point and it's got two x-intercept points, which are called the roots. But if you think about it, if you're one of these root points, what is your y-coordinate? Like, how high up are you? How low down are you? Like this point here, what's his y-coordinate? This point here, what's his y-coordinate? They're both 0, aren't they? So if you're a root point, which you can just think of as being an x-intercept, then the one thing that you definitely know is that you've got a y-coordinate equal to 0. In other words, if you're on the x-axis, your y is 0, the opposite letter is 0. Similarly, if you're this point here, the y-intercept, your x-coordinate is definitely 0, because any point on the y-axis has got an x-coordinate of 0, because it's 0 along the way. So that tells you that if you're the y-intercept, then you are guaranteed to have an x equals 0. In other words, for finding these key points, you just need to remember that it's the opposite letter that's 0. If you're on the x, your y is 0, and if you're on the y, your x is 0. And that principle is also true for the straight line graph topic. You know, if you're the y-intercept of a straight line, you've got an x-coordinate of 0. If you're the x-intercept, you've got a y-coordinate of 0. So we need to use this information if we're trying to work with the graphs of quadratic functions. So if I give you this function here, and notice, by the way, these are written in different ways. That's in completed square form, that's in factorized form, and that's one of the big challenges that students often face in quadratics is the different forms, but it doesn't matter what the form is because these principles are always true. So if we wanted to find the root points here, we would just say, okay, root points, they're the x-intercepts, let the y be 0. So I put a 0 here for y, that then gives me an equation to solve to get the x. This is a quadratic equation. You can solve it by separating into two mini equations like this. It's already been factorized. Then we just solve that to get a 6 and to get a -4, telling us that the two root points would be 6, 0 and -4, 0. Similarly, if we wanted to find the y-intercept, we just let the x's be 0. So we just go, okay, I'm just going to put zeros in the place of the two x variables. 0 minus 6 is -6, 0 plus 4 is 4. These two brackets are multiplying, so that will give you -24. So the y-intercept would be 0 minus 24. Okay, so just purely by using those two facts, we're able to really quickly actually find the two root points and then the y-intercept. Now in a question like this, that might be the question done, or more commonly it'll ask you to plot those points and then draw in the graph, and maybe ask you for other things as well, like the turning point or the line of symmetry, but we're just focusing on the root points and the y-intercept here. So what happens in this one? Well, the same thing happens. If you want to find the y-intercept, you're going to let the x be 0, and if you want to find the x-intercept, you're going to let the y be 0. Typically, when it's written in the completed square form, they don't ask for all of those points. But let's say, for example, we wanted to find the y-intercept. So for the y-intercept, we know we're going to let the x be 0. So you would just put a 0 in here like this, and then continue the calculation. Just in the same way we continued the calculation here, it's just in a slightly different format. So 0 take away 4 is -4 squared, like this. -4 all squared is 16, minus 2 like this, and that'll come out to be 14. So that y-intercept point is 0, positive, don't know why I put a negative there, 0, and a positive 14. So don't need the positive, so 0, 14. Okay, so again, this doesn't matter about the format, we're just using this key fact. This one, by the way, remember, is optimized for giving you the turning point, because the turning point is just these two numbers with the sign changed on that one, so that becomes a +4 and the -2 stays as a -2. So that is just by inspection, just by reading off the numbers, that would also give you the turning point. So if you see one of these in completed square form, they are essentially giving you the turning point by writing it in that form. Usually in this question, with this form, they ask for the y-intercept and the turning point. If they were asking, though, for the root points, Sometimes these don't have root points because they're just sort of floating in space like this. But if they do have root points, well, the same principle would apply. For the roots, the y equals 0, so you've got a 0 there. The reason they don't often ask for this one is because in this format, it's a slightly tricky equation to solve, which would involve sort of manipulating the algebra a bit like this, and to get rid of the square, you've got to take the square root, and it starts to wander off into territory that we don't really like, unless they give you really nice numbers. So usually they don't ask for that one. But the principle is still there. You would still just let the y be 0 and continue and solve in the same way. So if you want to get better at quadratic graphs, it is a no-brainer that you need to learn those two concepts, because it doesn't matter how they write the formula. They could even write it in a sort of trinomial format, which is the third type, I guess, something like this. And these same principles would apply to this, this, and this to get you these key points, which is going to get you most of the marks in a question like that.